So the first step is to drop the ping pong ball down the paper ramp, and then the ping pong ball will hit into the dominoes, which hits into the green magnets. The green magnets then slide down the rope, which hits into the baseball, which would then hit into the train, which hits into the second baseball and falls into the cup, which releases the second cup up here attached to the string, and inside the cup is the orange ball, which would then hit into the hand attached to the marker, which would hit into the dominoes, which hits into our car, which slides down the ramp, hits into the Jenga blocks. Then the Jenga blocks would hit into the pool ball, slide down the ramp, hit into our second pool ball, which then would hit this green ball attached to the string, which releases the plastic cup to reveal the dog food.
Newton's first law states that an object stays in uniform motion or constant rest until it is acted on by an outside force, and that can be seen when the baseball hits the train and it begins to move. Before the baseball hits the train, it is at rest. The train begins to move only after the outside force or the baseball hits it. Newton's second law of motion can be seen when the rubber ball, over here, hits the hand that pushes the marker forward. In order to get the hand to move forward, the ball had to provide enough force on the hand. A smaller ball would not have been sufficient enough to move the hand because it would not have enough force. This is because Newton's second law states that force equals mass times acceleration. So the mass and acceleration of the ball had to be enough multiplied together to equal the force required to push the hand forward. Newton's third law of motion can be seen when the marker swings forward and hits the domino. This action causes the domino to fall with the same momentum as the marker, but the reaction causes the domino and marker to have opposite velocities. So due to this fact, the domino falls forward this way and hits the other dominoes, while the marker swings backward with the same momentum. The law of conservation of energy states that energy cannot be created or destroyed, but can merely be transformed into other forms, and that can be seen when the pool ball over here is at the top of the ramp made out of pool sticks. Originally, the ball only has potential energy at the top. Once the ball is pushed down the ramp by the Jenga piece, all that potential energy transforms into kinetic energy as it rolls down. The amount of energy doesn't change, it simply transforms, and then the mass has to be a constant factor. Conservation of momentum can be seen when the domino hits the train. So when the domino over here hits the train here. Before the domino begins to fall, both the train and the dominoes are at rest. However, once the dominoes begin to fall after this point, and they hit the train, the momentum that's lost by the domino after it falls equals the momentum gained by the train when it goes down the ramp.